bottle of water again. And this is my bottle of water that I cheated with, that I had the hole in the bottom. But it's full of water, and why isn't water coming out of the hole? I don't see water coming out of the hole. Do you see water coming out of the hole?
No water.
Now that's strange. This bottle of water has a hole in it. I can prove it to you because watch.
What?
There's a hole in my bottle, dear Liza. Dear Liza. Okay, so there's a hole in the bottom of this. Now why is the water just staying in there? It's not magic, it's science. Now watch what happens when I take the cap off. Sorry. When I take the cap off, the water flows freely out, just as you would expect it to. But what most people don't realize, when I put the cap back on,
What?
the water stops. Now why do you think that is? Take the cap off.
Put the cap back on real quick.
Okay.
All right, so let's talk about what just happened. You had a bottle of water. You know I'm a great artist. And your bottle of water had water in it. And let's put a hole on the side. Hole was small. And then let's put a lid on the bottle. Okay. So when we started out, no water came out of the bottle. However, when we came along and we took the cap off, immediately water started coming out of the bottle. Why is that? Remember I said that air exerts pressure in all directions, and we are all under pressure, atmospheric pressure. In other words, if you're standing at sea level, you're very happy because you're by the sea. But if you're standing at sea level, you are under approximately 1 atmosphere of pressure. On an ideal day, 1 atmosphere of pressure. Of course, right now you're a little bit sad because the beaches are closed, but they will open again one day, and then we'll all be happy. You're under 1 atmosphere of pressure. Well, so this bottle sitting in Florida is also under 1 atmosphere of pressure. So when the bottle is open, that 1 atmosphere of pressure is able to push on the surface of the water and push the water out. Now, something else you can try is make the hole much bigger. And then it no longer works. Why? Because then the hole is big enough to actually draw air into the bottle, and then you'll get an air bubble in, water out. Air bubble in, water out. And that's kind of fun to watch. So this is something you can play around with at home. You could also take a 2-liter bottle, and you could put a series of 3 holes in it. Okay, this is my wonderful 2-liter bottle. I never wondered if I should be an art teacher or not. Okay, you're going to put 3 holes in it. Now, filling it up is a bit of a challenge. You're going to need 3 hands, so get someone to help you. A younger sibling who's bored from the quarantine would be a perfect assistant right now. So you're going to fill this bottle up with water. Okay, now, once again, with the lid off, air exerts pressure in all directions, and air pressure is going to push on the surface of the water. But you're going to notice something different. Yes, water is going to come out of all of the holes. We did this in a pipe with a hose outside, and I'm going to show you what happens, and then we'll be back to chat about it. All right, folks, we just have a bowl here full of water with 4 different holes, and notice how the water is coming out. Why do you think that's doing that? Now I'm going to remove the hose, and you can watch as the pressure decreases what happens. Of course, you noticed that in the bottom hole, water came out fastest, then with less force, and then with less force. And hopefully it's intuitive to you. The bottom hole has this much column of water, this much mass of water pushing on it, so it has a greater force, so therefore it's going to come out faster and shoot further. This second hole has less mass of water above it, so less force pushing on it, so it's going to shoot less far. And then, of course, this one has even less mass above it. Therefore, it's going to push out with less force. And that's why you get that nice pattern.